13.35. It says, consider a ring-shaped body, a particle with a mass, so figure E13.35. A particle with mass m is placed a distance x from the center of the ring along the line through the center of the ring and perpendicular to its plane. A. Calculate the gravitational potential energy in the system. Take the potential energy to be 0 when the two objects are far apart. B. Show that your answer to part A reduces to the expected result when x is much larger than the radius A of the ring. C. Use f of x equals negative du over dx to find the magnitude and direction of the force on the particle. D. Show that your answer to part C reduces the expected result when x is much larger than A. When the two values of u and f, what are the two values of u and f when, for part E, what are the two values of u and f when x equals 0? Explain why these results make sense. So, for part A, we're going to go u equals negative g m, big M, small m, divided by r. So then we can put, for r squared is going to equal x squared plus a squared. So then we can put that in for r and say the square root of x squared plus a squared, and that will be that. For part B, if x is much larger than a, then we can say that a is going to be basically 0. So then u then becomes negative g m divided by x, because x squared, square root of x squared is going to become x. For part C, we're doing force equals negative derivative of u all over dx. So then, the GMM equals d all over dx of, and since I'm getting rid of the negative because potential is negative GMM, of GMM divided by r. Well, I should put x squared plus a squared to the 1/2. Okay? So that's going to, the GMM can come out, so G big M little m times, and then the derivative of that inside part then becomes negative 1/2 x squared plus a squared to the negative 3/2 times 2x. So the x and the 2 and the 1/2 cancel. So then for our final answer for the force in the x, we're going to get negative g m times x divided by x squared plus a squared to the 3/2. So the direction for that is going to be towards the ring. Part D, because of the negative. If x equals 0, then the u, oh wait, for part D, x is much bigger than a, so a is basically 0. So then force of x is equal to negative g m divided by x squared. Okay? So, for part E, if x is equal to 0, then u is going to equal negative g m divided by a, because you just plug in x and solve for the thing, and then f of x equals negative g m divided by oh wait, times 0 divided by a cubed, or whatever, and then that just turns into 0. And that's because of balance forces and such.